In this video, we're going to solve for sides of a right triangle using SOH CAH TOA. SOH CAH TOA is abbreviated as SOH, CAH, and TOA, with SOH signifying sine, which we abbreviate as SIN, with this angle theta, and that's going to be equal to opposite over hypotenuse. Now the opposite over hypotenuse is directly linked to a right triangle in which we are given an angle which we saw as theta and three sides, with the side that's directly opposite of the right angle which we call the hypotenuse. Now the side over here we call opposite side, and that's because it is opposite of the angle of theta. The side that's next to the angle we call the adjacent side. We'll go through each one of these examples of SOH CAH TOA, with sine again being when we have the opposite side or the hypotenuse and our angle to figure out one of these missing sides. CHA is going to be denoted as cosine, which we denote as COS of the angle, is equal to the adjacent side over the hypotenuse. And TOA is going to stand as tangent, which we abbreviate as TAN, of the angle, is equal to opposite over adjacent. Knowing these basics, we can go ahead and solve examples of each instance of SOH CAH TOA. SOH, which again we abbreviate as sine of an angle, is equal to opposite over hypotenuse. If we have a right triangle that looks like this, with a right angle here, our angle for theta being 30, a value of 10 here, we can actually solve for this value of x using sine is equal to opposite over hypotenuse. We know that 10 is going to be our hypotenuse because it's opposite of our right angle. We know that x is going to be our opposite side because it's opposite of the 30 degrees. With that information, we can plug it into our equation, where we see that we have sine of our angle 30 degrees is equal to opposite, which is x, over 10. We can solve for x by multiplying both sides by 10. So x is going to be equal to 10 times the sine of 30. We can use a calculator to figure out the sine of 30 is going to be equal to 0.5. Multiplying those two numbers will give us an answer of 5. Doing another example, let's say for instance we have a right triangle in which we have a side of 25 and we're trying to solve for x here. The angle for this is going to be 60 degrees. We know that the side opposite of the right angle is going to be the hypotenuse. And the side opposite of our angle of 60 degrees will be our opposite side. Using the equation here, we would see that we have sine of 60 degrees is equal to 25 over x. When we have this, we can multiply both sides by x to cancel x out on this side, and divide by sine of 60 degrees on both sides. What that ends up doing is giving us x is equal to 25 over sine of 60. A shortcut that we can follow is actually just flipping out the x in sine of 60. Given that this is x, we can swap out these two numbers, putting x on top and sine of 60 on the bottom, and it will give us the same answer here. Simplifying this is going to give us a value of 25 over 0.866, which will equate to the hypotenuse being 28.87 as our final answer. CAH is going to be denoted as cosine of an angle is equal to adjacent over hypotenuse. If we have a right triangle, which we see here, with a right angle and an angle of 12 degrees, a value of 18 and x, we can use this cosine function to figure out x. The opposite side from the right angle is going to be the hypotenuse. And the side that is adjacent or next to our angle is our adjacent side. Plugging this into our equation, we're going to get cosine of 12 degrees is equal to x, our adjacent side, over a hypotenuse of 18. Solving for x is going to be equal to 18 times cosine of 12 degrees, which will simplify to 18 times 0.9744, which is equal to 17.54. Doing another example with cosine. If we have a right triangle with an angle of 62 and a side x and 7. Again, our side that is opposite of the right angle is going to be the hypotenuse, and the side that is next to our angle is always going to be adjacent. You'll notice that the angle is placed at the top, which differs from what we see on our example to the left. However, being that the angle is now at the top, the adjacent side will always be what is next to that angle. We can plug this into our equation, so cosine of 62 is equal to 7 over our hypotenuse of x. We can swap out these two values of x and cosine of 62 to where we'll get x is equal to 7 over cosine of 62, which is equal to 7 over 0.4695, which simplifies to 14.91. TOA is going to be denoted as tangent, which we say is tan, of an angle is equal to opposite over adjacent. If we have a right triangle denoted in this direction with a right angle and our angle of 25 degrees, we have a side length of 42 and x. Our side opposite of our 25 degrees will be opposite, and 42 being next to the 25 degrees will be our adjacent side. We can plug this into our equation of tan of 25 degrees is equal to opposite, which is x, over our adjacent side of 42. That's going to give us that x is equal to 42 times tan of 25, which is equal to 42 times 0.4663, which is equal to 19.58. Doing another example, if we have a right triangle that's in this direction with a right angle here, a side of 33 and x, and an angle here of 48 degrees. We know that this is our adjacent side, being that it is next to the angle, and this being our opposite side. We can plug this into our equation, so we get tan of 48 is equal to 33 over x. Swapping out x and tan of 48 will give us that x is going to be equal to 33 over tan of 48, which is equal to 33 over 1.1106, which tells us that x is going to be equal to 29.71.